Of all the ways the world could end, this might be the most ridiculously quiet. It wouldn't start with a bang, but with a silent, impossible darkness appearing in the palm of your hand. Imagine it. A perfect sphere of nothing, the size of a simple coin, hovering just above your skin. It wouldn't be hot, it wouldn't be cold, it would just be. And in that first silent second, before the universe screams, you'd be holding the most violent and extreme object in existence. This tiny, unassuming object would unravel not just our world, but the very fabric of space and time around it. So what happens in that first catastrophic second? The coin-sized object that just materialized in, let's say, a bustling city square isn't just a heavy piece of metal. It's a point of infinite density, an object with a gravitational pull so immense that nothing, not even light, can escape it. This isn't science fiction. It's the reality of a black hole. The size of a coin is its event horizon, the point of no return. But here's the mind-bending part. Its mass. For a black hole to be that small, it would have to have a mass roughly equivalent to our own planet. So, you have the entire mass of Earth compressed into a space smaller than your thumb. The immediate effect wouldn't be a gentle pull. It would be an instantaneous, violent obliteration. The air molecules around it would be the first to go, sucked in at nearly the speed of light. But the real spectacle is the ground. The black hole, with the mass of an entire planet, would possess a gravitational pull so fierce that it wouldn't just rest on the surface. It would plummet through the Earth's crust as if it were falling through mist. Imagine a bowling ball dropped on a single sheet of tissue paper. The ground, the buildings, the very bedrock of the city would offer zero resistance. It would be torn apart atom by atom, creating a superheated accretion disk of plasma, a swirling vortex of what used to be matter, now glowing hotter than the sun as it stretched and shredded into oblivion. The energy released from this initial plunge would be apocalyptic, a flash of gamma rays and X-rays so intense it would sterilize the entire hemisphere facing it. Anyone who wasn't immediately pulled in would be vaporized by this blast of pure energy. In less than a second, a city is gone, replaced by a gaping, glowing wound in the earth, and the cosmic coin has just begun its journey to the center of our world. This all sounds terrifyingly fast, but what does this journey to the center of the earth actually look like? Does it just sit there and eat? The black hole, now accelerating under its own immense gravity, wouldn't just fall. It would oscillate. It would plunge right through the Earth's core, and now the other side, perhaps erupting into the middle of the Indian Ocean. Then, like a horrifying pendulum, it would be pulled back again, swinging through the planet's heart. With each pass, it would consume more and more of the Earth's mantle and core. Imagine a cosmic sewing machine, stitching a path of destruction through the very fabric of our world. Each swing would take approximately 42 minutes to travel through the Earth and back again. And with every single pass, our planet's mass would be converted into a maelstrom of energy and absorbed by the black hole. The Earth would begin to tremble, not with the familiar rumble of an earthquake, but with a planet-wide shudder, a death rattle. The surface would crack, oceans would boil into space, and the atmosphere would be siphoned away. The process is horrifyingly efficient. As more of the Earth is consumed, the black hole's mass increases, which in turn increases its gravitational pull, making it consume matter even faster. It's a runaway reaction of cosmic proportions. Within a matter of hours, perhaps a day at most, the entire Earth would be gone, consumed by this tiny, insatiable object. So, the Earth is gone. A tragic but localized event. But what happens to the moon? Our loyal satellite has been faithfully orbiting the Earth for billions of years, held in place by our planet's gravity. But now, its dance partner has vanished, replaced by an object of the same mass but with a size of virtually zero. The moon wouldn't just fly off into space. Remember, the black hole at the center of where the Earth once was has the Earth's mass. The Moon would continue to orbit the black hole, just as it orbited the Earth. From a distance for a while, everything in our cosmic neighborhood would seem normal. The other planets, the Sun, they would all continue their celestial ballet, unaware that the third rock from the Sun had just performed a spectacular vanishing act. But this new arrangement is anything but stable. While the Moon orbits our new Earth-mass black hole, the dynamics have changed. The Earth was a large, gravitationally soft object. The black hole is a point of immense gravitational intensity. The tidal forces it would exert on the Moon would be extraordinary. Over time, the Moon would be slowly pulled closer, its orbit would decay, and it would begin to be stretched and deformed by the black hole's gravity. Eventually, it too would reach a point of no return, the Roche limit, where the tidal forces become stronger than the Moon's own gravity holding it together. It would be torn apart, forming a magnificent and terrifying ring of debris around the black hole, a shimmering monument to our lost world before being consumed, piece by piece. This is the end of the Earth-Moon system, but what about the bigger picture? What does this mean for the rest of the solar system and for the very fabric of space and time itself? As the black hole consumes the Earth and then the Moon, its mass grows. It's now more massive than the Earth was. This changes its gravitational influence on everything around it. Its orbit around the Sun would change. The orbits of Mars and Venus might be subtly, then dramatically perturbed. We've introduced a new, more powerful, and much more chaotic player onto the solar system stage. Over millennia, this could lead to a complete destabilization of the inner solar system, with planets being thrown into new eccentric orbits or even ejected from the solar system entirely. And what about time? Einstein's theory of general relativity tells us that massive objects warp space-time. Gravity is not a force, but a curvature of this fabric. A black hole is the ultimate expression of this. Near our coin-sized destroyer, time itself would slow to a crawl due to gravitational time dilation. If you could somehow have a clock that survived the plunge for every second that passed for it near the event horizon, years, then centuries, then millennia would pass for the rest of the universe. The end of our world would be, for a hypothetical observer at the edge, both instantaneous and an eternity. It's a place where our understanding of physics breaks down, a singularity where the familiar rules of the cosmos cease to apply. The legacy of our planet would be a scar in space-time, a tiny point of infinite density, a silent, dark monument to a world that was. And so, what started as a tiny, curious object ends up rewriting the future of our entire solar system, a final, ghostly testament to the day a coin-sized black hole appeared on Earth.